worked on 3 different methods for solving linear systems: graphing, substitution, and linear combinations. And all 3 are useful, but in certain situations it's better to choose one method over the other method. For graphing, a lot of times it's helpful when you want to approximate a solution, or sometimes just to see the graph, just to see that visual model and see where the lines are crossing. That can sometimes help you make decisions, as we'll see in a later example. Substitution is useful when one of the variables has a coefficient of 1 or -1. It's easy to solve for a variable when it has a coefficient of 1. And it's nice to use linear combinations when none of the variables have a coefficient of 1 or -1. Now in any case, you can use any of the methods. This is just a kind of a little cheat sheet of when you should use what method. So let's look at an example. A health food store mixes granola that costs them $4 per pound and raisins that cost them $2 per pound together to make 25 pounds of raisin granola. How many pounds of raisins should they include if they want the mixture to cost them $80? Now again, this can be confusing if you don't recognize that 2 things are happening here. We are talking about pounds and cost. So if I want to set up this linear system, think of it as 2 different things. I want to make 25 pounds. I'm going to have X pounds of granola and I'm going to have Y pounds of raisins. But altogether, that needs to equal 25 pounds. So there's pounds. Again, X represents our granola and Y represents our raisins. Now think of it in terms of money. Granola costs $4 per pound. Hopefully by now we recognize that as being 4x, because if 1 pound, you go 4 times 1, 2 pounds, 4 times 2, 3 pounds, 4 times 3, so on and so forth. And the same thing true is for our raisins here that cost $2 per pound, so we represent with a 2y. Represent that with a 2y. And we know that altogether that's going to cost $80. So 2 things. This equation represents how many pounds of raisins and granola we have. This equation represents the cost. So when we go now to solve this linear system, you can choose to graph it, use substitution, or combinations. But see here how our x and y have a coefficient of 1? It's probably easiest just to do substitution and just solve for one of the variables. It doesn't matter what variable you solve for. In this case, I'm just going to solve for x, and I'm going to do that by subtracting y from each side. I'm going to get that x equals 25 minus y, or 25 plus a -1y, however you'd like to write it. But now what we can do, that we've solved for our x, and it was pretty easy to do, is we can substitute this now in for x right here. So I can go 4 times, instead of saying x, we can say 25 plus a -1y plus 2 times y equals 80. Now the reason we want to do that is because now we're only dealing with one variable, just our y. Use your distributive property to solve. 4 times 25 is 100, plus 4 times a -1y is a -4y. Then we have our 2y still all equal to 80. Combine your like terms. -4y's and a +2y's, that's going to be a -2y. So we have 100 plus a -2y equals 80. And then subtract 100 off of each side. Just solving an equation like we know how to do. -2y equals a -20, and then we divide both sides by -2, and we get a +10. So this would be 10 pounds of raisins. Remember, our y represents raisins. Now if I go back to answer my question, it says how many pounds of raisins should they include? Well, that's my answer. 10 pounds. That's how many pounds of raisins we need. It doesn't ask us, but could we find the number of the amount of granola we need? Sure, just plug it in. If we plug 10 in here for y, what does x have to be? What plus 10 equals 25? 15. So if it asked us to, we could figure out that we would need 15 pounds of granola. But in this case, it just wants to know how many pounds of raisin, and that's 10 pounds. Again, setting up and solving, you're just making a choice now what method you'd like to use. And it's helpful to use substitution when your coefficient of your variables is 1 or -1.